Welcome to Accelerated Chemistry. We continue our investigation into the nature of things, having discussed mixed substances, or mixtures, that can be physically separated from each other, that is, using processes that do not alter the identity of the substances involved. Ultimately, however, through purification, we are able to isolate pure substances, substances that can no longer be separated by physical means. Compounds, the first of the pure substances that we identified in the previous video, are made of two or more elements chemically combined. These can be further separated according to chemical means, that is, through processes that would alter their identity, in order to isolate the elements by themselves, which have been organized into the periodic table. Now, physical and chemical changes are manifestations of physical and chemical properties. Physical properties are properties that a substance displays without changing its composition, whereas chemical properties are properties that a substance displays only by changing its composition. The smell of gasoline is a physical property. Gasoline does not change its composition when it exhibits its odor. The flammability of gasoline, however, is a chemical property, and gasoline does change its composition when it burns, turning into completely new substances, mostly carbon dioxide and water. Physical properties include odor, taste, color, appearance, melting point, boiling point, and density. Chemical properties include corrosiveness, flammability, acidity, toxicity, and other such characteristics. Now, the modern periodic table grew out of the work of Dmitry Mendeleev, a 19th century Russian chemistry professor. In his time, scientists had discovered about 65 different elements, and chemists had identified many of the properties of these elements, such as their relative masses, their chemical activity, and some of their physical properties. However, no one had developed any systematic way of organizing them. In 1869, Mendeleev noticed that certain groups of elements had similar properties. He also found that when he listed elements in order of increasing mass, these similar properties reoccurred in a periodic pattern. Mendeleev summarized these observations in the periodic law. When the elements are arranged in order of increasing mass, certain sets of properties reoccur periodically. Mendeleev organized the known elements in a table consisting of a series of rows in which mass increases from left to right. He arranged the rows, or periods, so that elements with similar properties fall in the same vertical columns, which we now call groups. A common error that many beginning students make when navigating the periodic table is to conflate metallic and non-metallic behavior with what state of matter the elements exist at room temperature. In order to clarify this, we should note that all elements can exist in the solid, liquid, and gaseous states, and that this physical property is really simply a function of their interparticle attractions and the surrounding temperature. Observe the differences that occur as temperature will now be intermittently increased. I will continue the video discussion at 6,000 Kelvin. Thus, at these temperatures or higher, as at the surface of stars, All elements exist in their gaseous state. Metals, therefore, are on the lower left side and middle of the periodic table and share some common properties. They are good conductors of heat and electricity. They can be pounded into flat sheets, or they are malleable. They can be drawn into wires, ductile. They are often shiny, and they tend to lose electrons when they undergo chemical changes. Nonmetals lie on the upper right side of the periodic table, and their dividing line between metals and nonmetals is the zigzag diagonal line running from boron to astatine. Nonmetals have varied properties. Some are solids at room temperature, others are liquids or gases. But typically, they tend to be poor conductors of heat and electricity, and they all tend to gain electrons when they undergo chemical changes. Many of the elements that lie along the zigzag diagonal line that divides metals and nonmetals are metalloids and exhibit mixed properties. Several metalloids are also classified as semiconductors because of their intermediate and highly temperature-dependent electrical conductivity. Our ability to change and control the conductivity of semiconductors makes them useful to us in the manufacture of electronic chips and circuits, central to computers, cellular telephones, and many other modern devices. Alkali metals occupy group 1 on the periodic table. These are extremely reactive, tending to lose their 1 valence electron extremely rapidly. Alkaline earth metals occupy group 2 on the periodic table. These are reactive, but not as nearly reactive as group 1. The transition metals occupy groups 3 through 12. These are all metals and thus also conductors of electricity. In general, they possess high density, high melting points, and high boiling points. Their properties are due to their metallic bonding of their outermost electrons, leading to cohesiveness, increasing their number of shared electrons between themselves. However, the group 12 metals have a much lower melting and boiling points, since their full outer shells prevent such bonding, which again tends to differentiate them from the accepted transition metals. Mercury is an excellent example of this. Metalloids, as we have discussed, are elements whose properties are intermediate between those of metals and nonmetals, many of them being semiconductors. Of the nonmetals, the halogens, occupying group 17 on the periodic table, should be noted as extremely reactive nonmetals. The most familiar may be chlorine, a greenish-yellow gas with a pungent odor. Because of its reactivity, chlorine is used as a sterilizing and disinfecting agent. Other halogens include bromine, a red-brown liquid that easily evaporates into a gas, iodine, a purple solid, and fluorine, a pale yellow gas. Finally, the noble gases occupying group 18 on the periodic table are extremely unreactive and exist as gases at room temperature. The essential takeaways of this video are as follows. Be sure to distinguish between periods and groups on the periodic table, as well as to be familiar with the major regions of the periodic table. Till next time, when we continue to explore the mysteries of the absolute, Crip.